They look and perform like something out of Star Wars. They work 8, 16, 24 hours a day, tirelessly, efficiently, stopping only long enough to power up for the next shift. But most importantly, they know their job and do it flawlessly. These are the Integrators from Litton. They're called the Integrators because it's their job to smooth the flow from materials to manufacture, from inventory to shipping, to integrate the manufacturing islands of automation, to speed the turn time between receiving the order and shipping it. The commands and instructions that may have taken you 2 or 3 seconds to read, understand, and respond to are handled in milliseconds by the Integrator microprocessor. They are not just predefined and unchangeable instructions embedded in the vehicle's guidance system, but come from a number of sources. Code markers in the guide path identifying locations, operational instructions, and precise stop points. Proximity signals from the RF field generated from the front of the vehicle to sense obstacles. Programmed instructions from its read-only and random access memories. And two-way conversation with the controller computer through infrared band transmitted signals. Listen to the reactions of people at NCR in Cambridge, Ohio, where Integrators were recently installed.
When the vehicles were first installed, people would sort of stop, come around, watch the vehicles a lot, sort of like the new kid on the block. And they had to sort of pass the test, which they did pass.
Well, at first, I was skeptical, very skeptical. I said, boy, they got to move an awful lot of units in just a little bit of time. And they don't move real fast. But surprisingly, steady is better.
I think they like to work around them because it makes them, makes their work area a high-tech environment.
As far as acceptance, the vehicles are accepted now. It's part of the everyday work experience here at NCR. People normally watch out for them. It's just like another person working here.
Make no mistake about it, it is one intelligent machine. But intelligence is only one part of it. Flexible, adaptable, upgradable. That's the other part, the part that pays off over the long haul. It starts here, on the floor, with this nearly invisible guide path. Nearly invisible except when stimulated by an ultraviolet light. Then it becomes a brightly glowing, high-contrast stripe, easily tracked by a sensor in the vehicle guidance head. The chemical guide path can be applied literally overnight in most installations, and reapplied just as quickly when changes in plant flow or manufacturing processes call for a fast rerouting of product movement. First, the old guide path is neutralized with an opaque coating. Then the new guide path is applied with this automatic dispenser floor striping machine. The chemical coating adheres to almost any surface: concrete, wood, tile, carpeting, even steel and raised computer or clean room floors. That means the Integrator can go virtually anywhere as long as the floor surface is relatively smooth and clean. Usable life expectancy of the coating is about a year to 15 months. Then it can be easily rejuvenated with a fresh application in a fraction of the time it took for the initial installation. It is the ability to respond quickly to layout changes in materials flow that most appeals to plant engineers, management, and high-echelon decision makers. Here's what they have to say about Integrator flexibility.
I think there were 3 vendors that were explored when we were looking for AGV vendors. Don't recall the names of the others right now. The technologies primarily were in different guide paths. And the final decision was that the current guide path technology was the way to go.
We looked at a few applications of automated material handling in-house, but the flexibility of your system was one of the most attractive features. Flexible in area of changing guide path from day-to-day operations.
I would say the vehicles have a lot more flexibility. The strategies that we're going to be seeing in the future, flexible manufacturing, the vehicles are readily adaptable to that. That's one thing that I am impressed with the guide path that is used by Litton.
To respond to day-to-day changes in our facility is one of the key factors. It comes down to flexibility. Everything is going to be narrowed down to flexibility.
The guidance system technology has been named UltraFlex. As with any unique and technologically advanced process, the name also serves as trademark. Ultra stands, first of all, for the ultraviolet light that is the basis of the operational system. And in the dictionary sense, it means going beyond the usual limit. Flex, of course, describes the flexibility of the system. UltraFlex shares its space with people and other vehicles. And even though under totally automated control, it is friendlier and more sympathetic to people than sometimes are other people. The Integrator's proximity detection system senses obstacles immediately to the front through an impedance-sensitive field. Solid objects cause a slight change in the shape of the field. Antennas mounted in the front of the vehicle pick up the change in impedance. The vehicle stops, sounds the alarm signal, then waits 3 seconds after the obstacle has moved or been moved to resume progress. A redundant contact detector backs up the proximity detection system. There are 2 contact-sensitive bumpers on the front tower, plus low-level bumpers to the front and sides. An onboard transceiver communicates with transceivers in other similarly equipped Integrator vehicles. When 2 vehicles approach a common guide path, the closer takes priority. Or, in other words, first come, first served. The other waits until the way is clear, then proceeds. The basic onboard microprocessor control system, with its programmed and embedded commands, plus operator override capabilities, is more than sufficient for most applications. But in large-scale facilities, where materials flow and production scheduling change rapidly, an external control system is called for. The vehicles can be controlled externally by any number of personal computer systems: IBM, NCR, AT&T, Compaq. These can operate independently or can be integrated with a host computer control system. Here, an NCR PC6 controls the movement, routing, and status of a number of vehicles. It communicates with the vehicles through 1 or more infrared transmitters placed at strategic locations throughout the plant. As the vehicle travels along a 20-foot communication zone guide path, it handshakes with the external control system, identifying itself and reporting its status. The ECS computer, after identifying the vehicle, issues its updated instructions, pickup and drop-off locations, and where to go after the drop-off has been made. When there are no further routing instructions, the computer parks the vehicle in a staging zone. Sensors, located at each pickup and drop-off station and linked to the ECS, tell the external control system computer which loads are ready for pickup and which shipping stations are open for drop-offs. Litton Integrators can be equipped with automated transfer devices designed to meet the specific requirements of almost any application. This standard shuttle transfer can handle either totes or flat-bottom pallets and enables the Integrator to transfer loads to and from relatively inexpensive passive pickup and drop-off stations. Along with assigning tasks and priorities, the ECS also sets up and maintains essential system files and the event log, a daily printed report showing material movement, shift changes, and various statistical data. The information can be accessed whenever needed, even when the ECS is transmitting new instructions to the vehicles. Battery charge status is also monitored by the ECS, and batteries can be changed in 5 minutes, ensuring a minimum of downtime. The entire system can be visually monitored on the computer screen. Because there is so much data available for review, The video screen is divided into 5 windows. The station window, showing the number of loads at each drop-off and pickup station. Vehicle status window, tells if the vehicle is en route to a pickup or drop-off point, in the battery recharge area, or in its manual mode. System status, the date and time, plus a monitoring of normal operations during logging on and online phases. Information request window, which shows the work list for all requests, tag numbers, priorities, as they have been originally assigned by traffic programmers, plus pickup and drop-off points. And the user window, used to adjust vehicle and material movement. As we said earlier, the Litton Integrator is one smart set of wheels. Ask the people who have come to depend on them.
The AGV has now become a member of the line, so to speak, and we're using it as part of our team effort in order to produce a good and reliable product.
We now have a constant flow of units on the pack line, which has improved my efficiency and my linearity of packing the units.
They coexist with the general workforce. There's no problem with sharing the aisle space. There's no problem with safety. That was a big concern to us, and we wanted to do extensive testing to assure ourselves that we didn't have any safety concerns. Once convinced that we don't, we have people walking down the same aisles, coexisting very well with the AGVs today. And we can expand on that, and I think take the AGVs anywhere that people go.
They are efficient. You can't beat them.
They're very reliable and they're consistent.
No problems at all. In fact, I could sell them to somebody. They work that well.
The Integrators from Litton. They're tough. They're reliable. They're intelligent. But most of all, they're adaptable, upgradable, flexible. They represent the leading edge in high-tech materials transport.